Thanks very much, Alex, the CEO of Navigine, for coming on the show.
Yes, thank you, Rupert. Very nice being here. Thanks for inviting.
Great. So I'll just introduce the market as I understand it that Navigine operates in, and then we can get into the agenda. So Navigine is a private company, but it relates to the public companies in the indoor sub-index of the Geospatial Index. So publicly traded competitors here are Maptelligent, Urban Immersive, Arway, Halma, Matterport, Inpixon, Beijing BD Star, Cisco, Ericsson, Securitas, CX App, Maps People, Next, Tech, and TrackX. So this sub-index has actually had negative growth in the past year of negative 20%. So it'll be interesting to find out how Navigine is progressing in comparison to these publicly traded industry peers. So perhaps, Alex, we can start off with the elevator pitch for Navigine.
Yes, thank you. At Navigine, we are doing software for precise indoor positioning and asset tracking. We have two products. The first one works like Google Maps, but when you enter shopping mall, train station, airport, you'll see yourself on a map and what objects are located nearby. And the second product we call it Asset Tracking Platform. It allows enterprises, warehouses, healthcare facilities, production facilities to help them to track assets and valuable things inside and outside of the building. So you have control and you'll know position of each and every asset you have. That's our product. We are working globally, have offices in US and Germany. And we are purely software company. We are not a hardware vendor. We work with more than 30 vendors and help our customers to find the best solution in terms of ROI. That's our core competitive advantage. So we could manipulate and provide many hardware vendors, which dramatically decrease the total cost of the ownership.
Great. Okay, so I can relate you then to a previous guest on the podcast, Arway. And they, I guess, are a competitor in the space of positioning people indoors. But you also operate in the niche of positioning objects indoors. And to me, that relates to the RTLS or real-time locator system industry, does it?
Yeah, you're right.
Yeah. Okay. All right. So could you talk then a little bit more about the niches that you operate in, how much you dominate them, or your plans to begin to dominate them more?
Okay, let's do it like this. So we are working, as you mentioned, it's a big department, let's call it IoT. And inside this IoT, we have indoor navigation and indoor asset tracking. That's two niches where we're working. During the last couple of years, we see a dramatic increase in demand in such kind of services because of one of the reasons was COVID. Actually, COVID affects a lot of this on this industry because of, for example, warehouses. They dramatically increase the speed of their operation. Yeah, all the logistic chain go through very dramatic changes. Yeah, and they try to be more digital right now. They implement new techniques, new software, and RTLS and smart asset tracking is one of the products that help them to be more efficient. Let's say it like this: it's the first thing that affects current market situation. The second one is, let's say, we see an increase in the number of technologies available on the market. And for example, 5 or 10 years ago, UWB was very precise and still is one of the most accurate technologies. But right now, the quality of the solutions that could be achieved with UWB dramatically increase, as well as the price goes down. And when the price for this hardware part goes down, you will have more business case that could be implemented.
So what does UWB mean?
UWB means ultra wideband. So there are different ways how you could implement RTLS system. It's unfortunately each and every time it's hardware based. So you can't do indoor positioning on asset tracking without a hardware. So your hardware is usually based on radio technology. You could use Bluetooth, Wi-Fi, ultra wideband, RFID. It's the most commonly used technology. And even ultrasound you could use. Yeah. Among this variety of different technologies, you could select the one which is more applicable to your case. And usually the criteria is the accuracy, cost, and the form factor. So that's the three main thing you need to take into account once you want to choose RTLS system for your production, for facility, for your healthcare facility, for your warehouse. Yeah, that's basically.
Fascinating. So do you work with, say, a warehouse to determine which of those 5 positioning options to implement? Do you do consulting about that?
It's very interesting. I mean, this market is quite new, and we could call it red ocean, because a lot of companies, they try to provide their solution and there are no standard. Yeah, it's lack of standard. That's why each and every time you meet your customer, you start educating them.
Yeah.
So you explain what kind of options available, what kind of solutions available, what are their limitations. And usually each and every project goes through a proof of concept.
Yep.
So you're not doing implementation in a warehouse. You start from a small office, one room or multiple rooms in a headquarters, where a local IT team just test your solution and understand how to implement, how to deploy, and how to use it. That's how it usually goes in a real case scenario.
Yeah, it's fascinating. Doing all these episodes with different companies from different sub-indexes of the Geospatial Index shows me how broad the positioning industry is. You know, I'm a real newbie to all of this. Yeah. Okay, so we have understood that you are positioning things like people and objects indoors. You have, as I understand it, a software solution that is agnostic regarding the technology that's used to achieve the positioning. You're saying that you go through a testing process on a small scale, on a case-by-case or client-by-client basis, where you determine the appropriate radio transmitting technology, basically, to achieve the positioning. And in the end, you come up with a solution, and you have some customers that you are going forward with these solutions. So in the end, though, an important part of positioning something is an algorithm. So are you able to step us through how our algorithms are used, or a simple example of an algorithm to come up with reliable positioning for a box going through a warehouse, for example?
Okay, yeah, let me try to explain that. So first of all, I would like to emphasize that at Navigine, we started as an engineering company, actually. We have 4 PhDs. Yeah, so I have a PhD in navigation area, so I'm an expert in not only indoor positioning, but also outdoor and mixed fused positioning. So at Navigine, we could work with almost any kind of sensors and any kind of measurements that position system could provide. It could be distances, it could be angles of arrivals, it could be time difference of arrival, RSSI values, and also inertial data. So based on this data, we could apply many filters. The most classical ones are Kalman filter, particle filter, and if we're talking about humans, So we usually implement a technique which called PDR, pedestrian dead reckoning. So, and I think I will try to explain how it works.
Sure.
Yeah, so we apply these techniques when we want to position a user inside a shopping mall, for example. Yeah, and you have a smartphone. Each and every smartphone right now already has some sensors. It's an accelerometer, gyroscope, and magnetometer. This sensor help us to understand your movement. So let's start from a step. So each step we made, we could detect each and every step we made with an accelerometer. So once we have accelerometer measurements, we see some peaks. And these peaks will represent the step moment.
Okay.
So once we see two peaks, we understand, okay, between these peaks, we have a step. Okay,
yep.
We have a step detector based on this accelerometer and the time frame data. Then we could estimate the step length by analyzing magnitude of the peak. Based on the magnitude of the peak and the time frame, we could estimate the step length. And using magnetometer and gyroscope, we could estimate the direction of a step. So, and based on that, step by step, we could calculate how you move from the starting point. With this algorithm, we can detect the starting point, but once we know it, for example, using Bluetooth data or Wi-Fi data, we could compute your relative position to this starting point. That's how this technique works. And these techniques help to decrease the number of hardware you need to set up inside the indoor space to provide this the indoor positioning service. So usually you need to set up Bluetooth, Wi-Fi access point to help algorithm to work more stable.
Is it like to almost because what you described there I appreciated the simple terms you used there. That was very helpful. I think the audience would be able to keep up with it. But you described dead reckoning essentially. So you have a known beginning point, and then you are essentially calculating the deviation in terms of rotation and translation from the origin. If I'm summarizing things correctly.
Yeah, you're right.
Yep. But this issue actually came up in my discussion with Arway. So they use a QR code to whose orientation and initial starting point is known, and the camera points at that, and you check in the phone essentially at that starting point. And then
you're right. It's a very interesting approach. I mean, using cameras, it's one of the trends that is now happening and dramatically increasing on the market. So different companies start using cameras to provide indoor and outdoor positioning. Airway, yeah, it's a good example, and you could use this initial localization as a starting point for PDR. I'm pretty sure that Airways they also use PDR in some cases.
Yeah, and then they said that there can be some drift, or essentially the deviations from the known starting point calculated or detected by, as you said, the magnetometer and accelerometer. Error can accumulate over time. So are you saying that your method or a method is to correct that using positions from beacons?
Yeah, there are I think 3 or 4 ways how to eliminate this drift. First one, yeah, you could scan QR codes, for example, or use AR. Another way is to use so-called particle filters. Let's assume that you have a map, and on this map you have marked white and black zones. Black zones are barriers, closed rooms, walls, pylons. So you will, for example, let's assume we are in a corridor building. Yeah, you have only a straight way.
Yep.
So, and once your algorithm knows that it's a straight way, it could use this map knowledge as a way to eliminate this yaw drift.
Yeah.
This is what particle filter does actually.
Okay, so and this is also what your software does.
Yeah, we do implement particle filter. In some cases, we use it, especially for human positioning, robot positioning. Yeah, it's very stable, reliable, and very effective technique. Let's say it like this. Using all these techniques, by the way, with a modern smartphone, you could reach an accuracy 2 to 3 meters, which is good enough to find shop inside a shopping mall or a parking spot. Yeah.
Wow. Okay. So has Navigine, are you involved with navigation of robots in warehouses?
Yeah, we are experimenting with wheel robots. It's not, let's say, it's not a robot that moved, which carries boxes inside the warehouse. It's let's call it last mile delivery robot.
Yep.
Yeah, we deliver something to your house from a small fulfillment center. Yeah. So this robot usually could have more sensors. For example, lidars and cameras, which is very informative. And it's like a small car. Yeah, it's like a small Tesla. All the set of sensors is the same, just in a small case. Let's say it like this.
Jeez, it must be exciting to work at Navigine. You guys are keeping up with all the modern trends and
Yeah, so we have a very strong R&D, and as we all have R&D background, engineering background, for us it's very so sometimes we stop ourselves just not to implement some new techniques in our core product and try to be more focused on the business side, to be honest. Yeah, it's one of the problems that we have.
good. All right. Okay, so it's great that we've had some simple discussion of algorithms. I'm glad we can go there on this show. So we are down then to an actual example of how these technologies and algorithms assisting Navigine, well, that Navigine is using to assist warehouses to increase efficiency. I understand from your website that you are able to show evidence of increasing efficiency with these technologies by about 10%. Could you talk more about that example?
Yeah, I will try to explain some business cases that is very important for warehouses and how Artila system could help with such a business case. The first and very common use case is, okay, I want to find a pallet. It should be here, but it's not here. Where it is? So if it's a large warehouse, sometimes you need to almost not even hours. You need days to find the box that you lost. And once you attach a small tag to each and every box or a pallet, you will have real-time position of this pallet in real time. And once you need to find something, you will need like seconds, not hours or days. That's our first use case. The second use case, okay, I need to collect an order, and for that, I need to go and pick up 10 or 15 different things from different boxes. I need to plan a route between them, and I need to plan this route in a way that it will be the shortest route or fastest route, or I want to avoid bottlenecks. Each and every warehouse, sometimes in the peak hours, they do have bottlenecks, and you need to find a way to go around. This helps, according to our experience and according to our data. Once the warehouse start using our road planning algorithm, they decrease the time spent for collecting purchases by 11%, which is very good. So, and in peak hours, it helps a lot. So when they have like a limited capacity or the amount of human resources is already like maximum, and you need to do more, this helps a lot. So
it's fascinating. You're bringing warehouses alive to me. You know, I think a lot of people don't. You know, they know that warehouses exist. They know that distribution centers, you know, for whatever online fashion website they're ordering from exist. But none of us really know what goes on inside. So it sounds like there's a lot of activity. I'm just imagining, You know, there must be tens of thousands of items in some warehouses to track.
It's tens of thousands, even hundreds of thousands. It depends on the size. I mean, large distribution centers, it's the area size of them is more than 1 million square feet. And if it's, of course, there are different warehouses. For example, Amazon warehouse is highly automated, many robots, a low amount of people. Yeah, but in some cases, you have hundreds or even thousands of employees inside, and you need to manage them.
So the positions of those, you have a holistic solution, if you like. You're able to position the workers. You're also able to position the objects that the workers are interacting with and solve the navigation problems, reduce congestion at peak times, especially with the humans and the objects.
Yeah, you're right. You could help them with the daily operation. And the third use case, it's analytics. Let's assume you are not somehow managing all this operation, you just collect data. You could understand the typical track of the order picker throughout the day. One order picker, another one, the third one. And at the end of the day, you could say, okay, this one is more effective. He could do like 100 orders per day, but the second one is only 10 orders. What's the difference?
Yep.
Based on this data, you could have some insights.
Yep.
Sometimes it gives you a very simple answer. Okay, this guy is just lazy, yeah. But in another case, you will understand that okay, we have here a bottleneck. For some reason, this aisle is always closed at this particular hour. Let's check what happens. Or we could go and ask, okay, why this particular order took so long to collect? Yeah. So once you have this data, you could split it in like a very small case and try to evaluate what happens in this particular case and how to improve your efficiency.
Okay. So I can. The insights here are really interesting. I can imagine companies running warehouses would love to have this software and improve their efficiencies with the insights. I can imagine you guys, do you have a dashboard or something that helps people understand?
Yeah, we have a dashboard, so we have many reports, but usually this dashboard, it's not something, I mean, usually the outcome goes from not a dashboard. So dashboard is something you look throughout the day, but this data should be collected. I mean, in real time, it's hard to understand how to improve something. So what value we provide in real time? Sometimes your RTLS system could be also used as a safety system because each and every tag you give to a worker, to employee, to your user could have a alert button, let's say it like this. Yeah. And once something happened, you could press this alert button. You will have in your dashboard a notification. You will send an SMS or even a call to your supervisor, and he could react.
Yeah, that's also really important. Yeah.
It's an SOS button. Another option is fall down alerts. So you know this warehouses, they have multi-floor environment usually, and if you fall down, this tag will automatically detect that and send the alerts, and it will decrease time needed to react, which usually, as an outcome, you will have like less injured people, which is always good.
To me, this just highlights really how much the positioning industry broadly has to contribute to all aspects of life. And to me, it almost feels like what you're offering is part of the nerve center, if you like, or the operations room. It's at the center of running what is a central part of our modern economy, you know, the distribution system or the warehouse. Yeah. So.
Yeah, you're right. But as usual, there is a backside of this coin. Yeah. So it's a privacy issue. So.
Right.
Yeah. So when you are tracked, so your supervisor could know where you are. So this is a challenge that should be very carefully eliminated during the deployment, let's say it like this. So what technique could we offer here is that, for example, when you track someone, there are zones that track in a zone. Yeah, for example, your resting zone or some other zones. So once you are inside the zone, you know that you are not tracked. It's very good practice. Another practice is that, okay, we only track you once something happens. So once you press an SOS button, we could track you. So the industry and technology is now mature enough to provide the solution that could eliminate these privacy concerns.
Yeah, and that relates, I think, to a news article I read recently about some complaints actually from Amazon workers that they were being pushed too hard by these, I guess, telematics human performance telematics tracking systems.
So because once you know everything, because some of the techs, to be honest, they could provide your pulse level, blood pressure, so you could be controlled like 100%, and that's not even once you work, it's not good for everyone. You should be very careful with that, and you should understand why you need to implement the tracking, how you will explain this to your labor, and that's all. It's an operational challenge, let's say like this. It's very interesting.
No,
and it depends from country to country, from region to region, because of the labors, because of the local laws. It's very interesting.
No, I'm glad we've been able to discuss the human side of this and the implications for stress levels too. We don't want to create an Orwellian system of control. So questions come up for me outside of the agenda, but I think a lot of listeners might be interested in this. So does Amazon have their own in-house Navigine software solution, if you like? Would you ever have a chance to sell to a company like Amazon, or do they take care of it all themselves? Do you know?
Yeah, we work with Fortune 500 companies. I can't name them because of the NDA, but you're right. So each and every company, I'm pretty sure that each and every country, in some cases, they will need or already use RTLS system for many kind of purposes. For example, for training. So once you train and you do something in the physical world, RTLS system could keep your data, and you will measure performance in these training centers. We work with many oil and gas companies. Their training facilities, when they keep track of their employees once they are learning, to help them find the mistakes, to help them to find the places where they could improve their operations. It's a good practice. And it's not only oil and gas, it's production, it's healthcare. In healthcare, we help to track valuable assets like infusion pump, for example, or wheelchairs. Because each and every hospital, they do have a lot of wheelchairs, but once you need it, they're somewhere inside. It's hard to find. And they spend a lot of time just to find something. In total, it's like you could precisely compute the loss you have throughout the year, for example. So I'm pretty sure that each and every physical company would need this system. Of course, if you only provide like IT services, it's hard to understand why you need it. But if you have something physical, you need to track something.
I feel like, sure. Sorry to interrupt. I just want to say, I feel like I'm at the point where I've got like a tagline for Navigine or your industry. It's essentially reducing the time to find things, and maybe people don't understand, but that actually has a significant economic impact. It sounds like.
Actually, it's like three basic questions we have in our life: what, when, and where. So, and using RTLS and using Navigine, you'll have an answer to where. So,
and the time to discover where has been reduced significantly. Yeah. Great. Okay, so my next question, I'm going to actually ask you to comment directly on a market competitor. So what is your opinion of indoor navigation systems without beacons as promoted, for example, by Arway?
You mean the systems that use, for example, cameras? Yeah.
Yeah, because our way is promoting this, so I'm asking you to comment directly on whether that's sensible.
It's a very interesting approach. We also experimenting with this AR approach, and we do have our own SDK which could work using cameras and augmented reality features. I think that for some application, it's a great approach. So, for example, when you want to find your gate at the airport or your track on the train station. But the limitation of this approach, it's you need a smartphone. So you need a smartphone with a camera. That's one. So you can't use it in a hospital, for example, because of the privacy. When you use camera,
yep.
You're always like filming someone else, which is not very good. Yeah. Or you can't use it in a corporate building on a production facility. So you limit yourself in environments. That's that first thing. The second thing is that still, I don't know the exact numbers, but still a lot of people, they imagine map as a two-dimensional paper. Yeah, that's why we have commonly we have like Google Maps or other applications. You see a two-dimensional map and you pinpoint yourself on the map. And once you switch this user experience to like a screen and this arrow,
yeah,
I mean, I think that my grandmother can't find can't find her way in a shopping mall using this technique. So it's another user experience. But once you are young, for you it's okay. Oh, it's nice. Yeah, why not? So
another one for me is that it can get tiring holding your phone up all the time.
Yeah, phone is one of the form factors. But let's imagine this smart glass.
Sure.
Yeah, it's more designed for such kind of screens.
Yeah. Okay, so then I have to slip in another question. What's your opinion on Apple Vision Pro and this new spatial computing trend? Is that going to impact the industry?
Yes, I mean, we start experimenting with this form factor with, I forgot, the Google Glass, yeah, which appears 2014.
Yeah, 10 years ago.
Yeah, we created an app for Google Glass, and you were able to see the direction you need to go through a Google Glass.
Awesome.
Yeah, so, but I don't know why, but Google closed the project. In some of the production facilities, I know they use these devices to help the employees to do, for example, maintenance and repair. So inside your glass, you have a tutor who is sitting in a headquarters and help you to with the repairing work, for example. Yeah, that's a good idea, and for some use cases, I think it will provide a very, let's say, very good level of trust, let's say it like this. So once you send a not very experienced worker to repair a thing, and he have a buddy which could help him. Yeah. So
to me, it's like a sci-fi movie. Like if that actually starts becoming routine, I would feel like we're in the future.
Yeah, but imagine, so like you need to have a smartphone, a tag, a glass, a gas detector, a smart helmet, and a lot of these devices. So you like a robot, yeah. So.
I agree, and there's also the risk, especially in oil and gas, that none of those are an ignition source. If you've got an electronic device stuck on your head that can cause, gas to catch fire, so there's a significant.
We work with many production facilities, and this regulations is very strict. Once we are going to oil and gas refineries, for example, all the equipment should be certified, explosion proof, and still there is a lack of the hardware which could go through this certification. That's one of the challenges we have right now. Yeah,
big barrier to adoption. Yeah. It seems like the next thing is the handoff between RTLS systems. That's the next thing.
Yeah. I mean, IoT is growing, microelectronics is growing, It will be cheap, low cost, low power consumptive. Yeah, very soon.
So really, are we talking about then what IoT actually enables here? Because sometimes I've got the impression that IoT is like, it's like the AI hype, you know, but actually it seems like it's real, and this is an example of the benefit of IoT.
Yeah. IoT provides a basic, let's say, infrastructure level, like connectivity, yeah, because you can't create RTLS system without connectivity. So once we have connectivity coverage, cheap, robust, scalable connectivity all around the world, you will have the applications like RTLS on top of this connectivity very soon.
Right. And so this has implications then for the semiconductor industry. Essentially, what we're talking about is a chip in everything. Once there's a chip in everything, we have IoT for the planet. And we have, what can I say, a segmented general RTLS global system.
Yeah.
So there's linkages here then to, because I also have a sub-index for GNSS chip systems. You've got, I mean, I was updating it at midnight last night because I was looking at uBlocks, which is, as I understand, the leader for GNSS chips. They're from Switzerland. But there's also the likes of Broadcom. Well, I'll just say that there's a whole bunch of competitors there. So this is also a useful conversation for the linkages to other sub-indexes within the Geospatial Index. So.
Yeah.
And I feel like then we can have another whole episode.
Yeah, you're right. I mean, if you will want to learn more about GNSS, it will definitely it will definitely interesting for your subscribers, and I think that it's another big thing. I mean, GNSS, it's kind of the same technology with RTLS on a more scale, but as well, GNSS has a very strong background. I mean, in defense and military, yeah. So all this technology goes from defense industry. That's why we have a lot of competitors. Each and every country wants to have their own solution.
Right. Yeah.
Be independent.
Sure. Yeah, I was looking at one of uBlocks' recent shareholder presentations, and they did flag indoor positioning as an area of interest for them for expansion.
They developed a chip which utilize GPS, Bluetooth, Wi-Fi, cellular connectivity and they could combine all this technology to provide better positioning. Yeah, so all this communication, radio technology enabled devices, they all could be used for positioning. Yeah, so wow, and all technologies could substitute GNSS or used together with GNSS to provide more precise result.
Okay, so this is a comprehensive positioning solution then for both outdoor and indoor positioning, and the semiconductor industry seems to be facilitating that next development. Okay, we have a final question here about your new open source solution and the implications for science, technology, engineering, and mathematics outreach. I'm interested in what you're doing here to engage with the public and the next generation.
Yeah, thanks for that question. So the open source approach and this direction is very important for us. We try to be presented in this field, and we try to cooperate with universities under the STEM approach. For example, some of our algorithms and solutions that we published for free usage are actually utilized by universities. And every month we get more than 15 requests from different universities around the world. Mostly it's students who do their bachelor diplomas. We provide them with our solution, even for free. They ask us questions. We try to help them. And at the end of the day, they create, for example, mobile application for navigation inside their office environment or in university environment. That's the common use case. For us, it's very interesting because we know that these students, once they go to companies, they will remember us, and maybe when they will have their next project in indoor positioning, they will get back to us and we could do something together. And also, let me shed some light on our activities for STEM. My team is preparing a new campaign on deepening our relationship with universities and young developers. which will include roundtable discussions and joint research for indoor positioning and RTLS. And I think it will help to foster young specialists in the domain of navigation and engineering. We will try to provide our expertise, to share our expertise with them, and to find jointly new business cases, new approaches that we could then reuse together.
Right, fantastic. You're making me want to go and download the software and have a go myself.
Yeah. I mean, the very tricky question is how to get money, but let's start with them, and then we will try to understand how to do how to make business on them.
No, yeah, great. Okay, so I want to put in a final question if I could, and it's about at least amongst your publicly traded competitors, what the growth rate seems to be, at least in the past year. And I know that I probably don't have a representative sample. I only have, 15 or so publicly traded indoor positioning competitors, but it does seem that in the past year, the industry has contracted a bit. What about your own growth rate? Maybe not the precise growth rate, but how are things looking, at least within Navigine?
Yeah, it's interesting. So let me say it like this. So the growth that we have, last year it was more than 60% in terms of revenue. But we have a very huge growth in US and Canada and in Asia. So we see that in Asia, the factories, small factories and production facilities, they start implementing new IT technologies, and we see a huge market opportunities there. But as you maybe know, that when you try to sell some services in Asia, your prices usually goes down. And it's a tricky thing. You want to implement something, you know that they will need your product, but the price is very low there. So you need to be very clear from the very beginning with that region, with clients coming from that region, and you need to set up expectation from the very beginning. So sometimes it's hard, but also it's very interesting because the amount of use cases they have is like tens, hundreds, thousands, I think. So the production demand is growing, and I think that this is the main revenue driver for us for the next years. I know that in US, for example, many competitors, they focused on office environment, healthcare environment, and such industries are, let's say, they're more or less stable. They are not growing fast.
Yeah.
That's why maybe it affects the growth of the market. But once you go to a new niche, new geography, you have a huge opportunity, let's say it like this, but as well a huge challenge. Yeah, it's always goes together.
Okay. Well, I feel lucky to be profiling a company that's been going against the trend in the industry. I'm glad you're doing so well. Okay, well, I guess to sum up, Alex, your background shows something from the future. I have been very grateful for you to tell us about what the future will be like, at least in the indoor positioning industry. And yeah, I look forward to maybe catching up again about how you're going over the years to come. So thanks very much.
Thank you, Wilfred, for very nice conversation. So let's meet in, I don't know, 5 years, yeah, and we will have like very robust RTLS system everywhere, and we will be happy to use them without any privacy concerns.